So in our previous video, we looked at finding general solutions. Now we're going to find particular solutions, which is one individual solution to our differential equation. All right, so this is called a particular solution. They're going to give us some extra information about our answer so we can narrow it down from a general set but still have that kind of plus c hanging out to one individual answer that doesn't have any extra variables in it. All right, and that's called a particular solution because it's a very specific solution. All right, the strategy is going to be the same. All right, still, the only way we know how to solve differential equations is by separating the variables. So that's going to be the same. Once you separate, you integrate. And now we just add in. Now we have some extra information so we can figure out what that c is. So once we take our antiderivatives, we're going to plug in the stuff we know to figure out c. And then after you know c, then you can solve for y. You technically could transpose these two steps. You could solve for y first and then plug in to get c, but by solving for y, you're making the equation more complicated. So generally, it's a good idea to solve for c here and then solve for y last. All right, so let's see how to do this. So find the particular solution to this when we know certain specifics. If y equals 7, then x has to be 1. All right, well, the first two steps are still going to be the same. I'm still going to multiply by dx on both sides. In this case, there's no y, so I just get dy equals 4x dx. I take integrals. Derivative of dy, just 1 dy turns into y. Derivative of 4x turns into 2x squared plus c. Right. So that is my kind of general solution. In this case, it's actually already solved for y, so really we've already done step 4 without having to do step 3 yet. But now the next thing I'll do is plug in. I know when y is 7, when x is 1. So this gives me an equation I can solve for c. And I get that c equals 5. So now I plug that into my general solution, and I get my particular solution, because now there's no extra variable c, it's just a number 5. So this is my final answer, my particular solution to this one. All right, next up, same thing. All right, first steps, always going to be separating the variables. So in this case, I have to multiply by dx and y. I get y equals x plus 1 dx, dy, I've got the dy over here. Then I take my integrals. The antiderivative of y is going to be y squared over 2. Antiderivative of x plus 1 is going to be x squared over 2 plus x plus c. And we know when we plug in 0 for x, we're going to get negative 2 for y. All right, so now I'm going to have this equation. I'm going to write it kind of to the side so I don't run out of room. Negative 2 squared over 2 equals, all this stuff is going to end up being 0. So negative 2 squared is 4, and 2 is c. All right, so now I know that c is 2, so I can plug that in over here. And now I can figure out what y is. So first thing I have to do is multiply everything by 2. And then take square roots of everything. All right, here's one thing you have to be careful with. If I just wrote this as my final answer, it would actually be wrong, even though it looks like everything I've done so far is right. And that's because there's one thing that I omitted, and that's when you take the square root of both sides of an equation, you're supposed to get a plus or minus. But it doesn't make sense for y to be equal to two things. So in general, with our general solutions, we don't need to put the plus or minus. But here we know if I plug in a number, I get a negative number out, which is telling me I want the minus sign. So I want to get rid of the plus sign and just have the minus sign. So I actually want the negative square root to make sure when I do put in, to get my particular solution, when I do put in 0, I get negative 2. If you take the square root of a number, you always get a positive number, but that negative will make sure it actually fits the initial condition we have. All right, one more example right here. Again, hopefully it's a little tedious and you're just seeing that you're doing the same thing every time to start. All right, so here we're going to get dy over y equals 3x squared dx. And that allows me to integrate both sides. All right, on the left-hand side, I'm going to get the natural log of y. Just remember, when you take the antiderivative of 1 over something, you get the natural log. On the right-hand side, I'm going to get x cubed plus c. And I know when I plug in 0, I get 2 for y. So the natural log of 2 equals c. Because that x cubed just turns into 0. So now my equation is the natural log of y equals x cubed plus 2. And to get rid of that natural log, I've raised both sides with an exponential. So y is e to the x cubed plus 2. That's our same steps we've done. Again, just that extra step of figuring out what c is along the way. So here's one for you to try on your own. I figure out this particular solution to this differential equation. So go ahead and pause the video, and we'll come back and look at the solution. And your final answer should look something like this at the bottom. All right, so again, really quickly, go through the steps. Separate the variables, so x is to the right, y is to the left. Antiderivatives, the antiderivative of y, or 2y is y squared. Antiderivative of 3x is 3x squared divided by 2. All right, now, at this step, we can figure out what c is, so plugging in 0 for x and 10 for y figures out that c is 100. And then to figure out y now, we just divide both, or sorry, take the square root of both sides. And here, again, we should technically get a plus or minus, but because we know our answer when we plug in 0 should be 10, we want to get the positive square root. So in class, we're going to practice finding more general and particular solutions to differential equations. We'll probably do more particular solutions because those just involve finding general solutions anyways, just one extra step. All right, we're also going to have some time to prepare for our next unit test.